Hello everyone. Today we'll talk about scalability in social media platforms and exploration of how social media platforms tackle the challenge of scaling their services to accommodate growing user bases. This case study delves into the scalability assessment of Facebook, Twitter, and Instagram, examining the methods and technologies employed to handle increasing demand. First, to talk a definition of scalability in social media. We divided it into four parts. First is user growth. Scalability in social media refers to the ability to accommodate a rapidly growing number of users. Message throughput. It involves efficiently handling a large volume of message, posts, and interactions of the platform. Database size. The capacity to manage a vast amount of data while maintaining responsiveness and reliability. Network traffic, the capability to manage high network traffic without experiencing downtime or performance degradation. So let's stop for each part of them. User growth. Facebook needs to handle over 2.8 billion users. Twitter manages around 396 million daily users. Instagram caters to over 2 billion monthly users. So message throughput. Facebook processes massive amount of user-generated content. Twitter handles high tweet volumes and engagement signals. Instagram manages image, video uploads into interactions. Database size. Facebook deals with vast databases containing user data and activity logs. Twitter manages large databases of tweets, user profiles, and engagement metrics. Instagram handles substantial databases of media content, user profiles, and interactions. Network traffic. Facebook manages data exchanges between users, servers, and CDNs. Twitter handles real-time data exchanges, API calls, and media transfers. Instagram manages media transfers, API requests, and CDN-based content delivery. So next, case study selections. For this case study, we'll focus on Facebook, Twitter, and Instagram due to their massive user base, complex architecture, and historical scalability challenges. Facebook. Facebook. Facebook first is large user base. Facebook has one of the largest user bases globally with billions of active users. Its scalability challenges stem from managing such as fast user network, including user-generated content, interaction, and data processing. Second is complex architecture. Facebook's architecture has evolved over the years to handle scalability issues efficiently. It utilizes distributed system, sharding techniques for databases, caching layers, and content delivery networks to ensure smooth performance and scalability. Twitter, significant user traffic. Twitter experienced significant spikes in user traffic during trending events, breaking news, and viral content sharing. This high volume of real-time data process scalability challenges in terms of message throughput, data processing, and system responsiveness. Architectural evolution. Twitter has undergone architectural transformation, moving toward a microservice-based architecture. Technologies like Apache Mesos and the Kubernetes are used for container orchestration, while distributed databases like Cassandra handle tweet storage and retrieval. This architectural advancement aim to enhance scalability and fault tolerance. Instagram. Massive media content. Instagram scalability challenges revolve around managing a massive amount of media content, including images and videos shared by users. Handling media uploads, content delivery, and user interactions at scale requires robust infrastructure and optimization strategies. Integration with Facebook. As part of the Facebook ecosystem, Instagram benefits from shared infrastructure and scalability solutions developed by Facebook. This integration helps in addressing scalability challenges effectively, such as database partitioning, caching mechanism, and CDN utilization. Scalability analysis. Facebook employs a distributed architecture with data partitioning strategies to manage its vast user data efficiently. It utilizes shaping techniques for database caching layers and content delivery networks to enhance performance and scalability. Twitter utilizes a microservices architecture and relies on technologies like Apache Mesos and the Kubernetes for container orchestration. It employs distributed database for handling tweets, caching for performance optimization, and CDN for content delivery to improve scalability. Instagram leverages Facebook's infrastructure since it's owned by Facebook. It uses sharding for database caching layers and CDNs to manage high traffic and ensure scalability for media content sharing. Investigate architectural components. Distributed database utilize a network of servers, enhancing data availability and reliability. Caching layers improve system performance by storing frequently accessed data. Content delivery networks optimize content delivery by using distributed servers globally. Performance benchmarking. First is response times. Is measuring response times involves analyzing the time taken by the platform to respond to various user actions. Facebook prioritizes fast responses through caching and CDNs for actions like posting, feed loading, and content searching. Twitter focuses on real-time updates with low response times for tweeting, retweeting, and tweet loading. Instagram emphasizes quick content delivery with CDNs and data optimization for uploads, story viewing, and the feed scrolling. System throughput refers to platform's capacity to process and handle a certain volume of requests or messages within a given time frame. Facebook handles a high volume of interactions like likes and shares using scalable infrastructure and distributed databases for efficient throughput. Twitter prioritizes message delivery and user interactions, employing sharding for scalability and the message queues for high throughput. Instagram manages media uploads and user engagement with optimized storage system, data pipelines, and CDN caching for repeat content delivery. Resource utilization. Monitoring resource utilization involves tracking the usage of key system resources such as CPU, memory, disk, input, output, and network bandwidth. This helps evaluate how efficiently the platforms utilize resources to handle user traffic. Facebook optimizes resources by dynamically scaling services based on traffic, efficient database indexing, and content caching to reduce server load. Twitter optimizes resources with database sharing and memory caching and edge computing for low latency and improved system responsiveness. Instagram optimizes resources with image video compression, efficient data retrieval, and CDN caching for faster content delivery and reduced storage bandwidth usage. Case study evaluation and recommendations. Evolution of Facebook. Facebook demonstrated strong scalability in handling a massive volume of user interactions. Their use of distributed database and load balancing techniques contributes to efficient resource utilization. However, they may be challenged during peak usage periods and the centralized component could become bottlenecked. Recommendations for Facebook. First is adopt microservice architecture for modularity and scalability. Optimize database schemas and queries for enhanced performance. Implement distributed caching strategies to reduce server load. Explore serverless computing for scalability and cost efficiency. Twitter evaluation. Twitter showcases efficient resource utilization with database sharing and in-memory caching. They excel in high system throughput for message delivery and real-time updates, yet their scalability limitations during suddenly spiking is in user activity and potential latency issues. Recommendations for Twitter. Refine database sharing strategies for improved scalability. enhance in-memory caching mechanism for frequently accessed data, utilize edge computing for faster content delivery and reduced latency, implement predictive scaling based on usage trends for better capacity planning. Instagram evaluation. Instagram exhibits efficient resource utilization with media compression and CDN caching. They excel in rapid content delivery and user engagement strategies. However, managing increasing media uploads and scalability in content delivery may pose challenges. Recommendations: optimize image and video compression techniques for reduced bandwidth usage. Implement scalable data retrieval mechanism for media content management. Scale CDN caching strategies to handle growing content delivery demands. Conduct regular performance audits and stress tests for optimal capacity planning. So, in conclusion, and future considerations, after evaluating the scalability of Facebook, Twitter, and Instagram, it's crucial to consider future implications and enhancements. Two recommendations for improving scalability in social media platforms will influence their long-term success and user satisfaction. Understanding the scalability challenges and architectural evolution will shape the future of social media. That's all for today. Goodbye.